Hi everyone, my name is Walden Gautier Tanoto, and I am a high school student from Indonesia. Today, I am excited to introduce my invention, the calculus calculator. Why did I create the calculus calculator? It's because I want to help students around the world who find calculus difficult to learn. Did you know that around 22 million students study calculus every year? In the beginning, I had the same problem as many of you. After many hours of studying AP Calculus AB and BC, I finally gained a strong understanding of calculus. Now, I would like to share my knowledge about calculus by coding it into the calculus calculator. Thanks to the skills I have learned from CS50x, Harvard University's famous online computer science course, it took me 8 months to complete this project, as I worked on it in my spare time after school and after finishing my work at home. I hope my calculus calculator can help you and make your journey to understanding calculus much easier. Guys, now I'm going to show you my invention, the calculus calculator. Here are the calculus calculator. There are a total of 64 programs. Now I'm going to test my calculus calculator. Guys, here are 64 modules from AP Calculus AB and AP Calculus BC. Now I'm going to randomly pick 5 modules to prove that my calculus calculator works. Now I'm going to randomly pick 5. The first one is inflection. The second one is trapezoidal function. The third one is left Riemann function. The fourth one is ratio test. And the last one is alt-error test. Now I'm going to prove the inflection module. First, we run the code and then type the problem. And we can see that both of them has the same values. So it has no points of inflection. Let's see if it's correct. Yay, it's correct. Now we can see how they solve it. First you differentiate it, and then you differentiate it again. Then we find that x equals to -3 is where it's equals to 0. Then we plug in a value, x equals to -6 and x equals to 0, to see that both of them is concave down, which means it has no points of inflections. Now we're going to prove the ratio test. We type this. The limit is 0. The series converges. Now I'm going to check. Yay, it's correct again. 3 more to go. This is how they solve it. Now I'm going to prove the left Riemann function. 3 equal subdivisions. X at left is 2. X at right is 5. And then the function is the total area is 47 out of 60. And let's see if it's correct. Yay, it's correct again. This is how they solve it manually. X5 minus 2 divided by 3 equals subdivision is 1. So each subdivision is 1 unit width. Then plug in the values of 2, 3, and 4. And then 1 times the value of the height is equals to the area. Now I'm going to prove the trapezoidal function program. 3 equal subdivisions. 0.5 is x at the left. 2 is x at the right. The function is 2 divided by x. The total area is 35 out of 12. Now let's see if it's correct. Yay, it's correct again. This is how you solve it manually. 2 minus 0.5 divided by 3 is 0.5. So each subdivision has a width of 0.5 units. And then plug in the values for 0.5, 1, 1.5, and 2 into the function. Then the width times the 0.5 plus 1, and then add them together, then divide it. And then the next one is 0.5 times function at 1 plus function at 1.5, added together and divided by 2. And then 0.5 times function at 1.5 plus 2, added together and then divided by 2. You can simplify it into 0.5 divided by 2 equals to 0.25, and then put the function, which is 2 out of x. This here is 2 out of 0.5 plus 2 times 2 out of 1 plus 2 times 2 out of 1.5 plus 2 out of 2. It equals to 35 out of 12. Now I'm going to prove that my odd error test works. First, run the program. And then write this function. And then since we're finding the error bound, we need the top, which is 3. The error bound is negative, and hence the approximation is an overestimate. What is the absolute value of the error bound? Since it's the absolute value, we do not need the negative. Run to the 6 decimal places. 1, 2, 3, 4, 5, 6. Since it's 7, it is added 1, which is 2 plus 1, 3. Now I'm going to check. Yay, it works. This is how you do it manually. Since the top is 3, the first omitted term in the series is 4. So n, you change it to 4. 4 plus 1 is 5. And then 2 times 4 is 8, plus 1 is 9. Becomes this. In conclusion, the error bound is negative and hence the approximation is an overestimate. The absolute value of the error bound rounded to 6 decimal places is 0.000003. Now, it's confirmed that my calculus calculator is working very well. I truly believe that my calculus calculator can make a huge impact on the world. I know that my invention is still far from perfect, especially in terms of user-friendliness. I plan to build a user interface for my calculus calculator, but not yet, since I still need to learn how to do it properly. I still have a lot to learn. I plan to continue my studies in computer science, focusing on artificial intelligence, so that I can create more products that are both functional and user-friendly. I would like to express my appreciation to Mr. Salkan from Khan Academy for making AP Calculus AB and BC courses accessible to millions of students worldwide. Last but not least, I am always open to feedback and eager to improve, so I can help even more people around the world. Please feel free to leave a comment and don't forget to subscribe and give this video a thumbs up. See you guys in my next projects, and thank you very much for your support.